Today we're going to be talking about the electrical top 10. So these are kind of the different type of product sets that we use commonly and that are really popular amongst other boaters. PYS is a company that basically focuses on electrical and electronic systems on boats. So we specialize, and pretty much today's topic is going to be the most common items that we install on boats and why owners choose them and what you should be looking for. I guess I should talk about that. This is pretty much the agenda. So the format of the presentation for every single product set that's going to be out there, I'm going to tell you what and why that product, what you should be looking for when you buy that product, what are things that you should make sure you have as you're buying that type of product. And then also the last slide, so we're going to be doing 3 slides per product, is going to be the installation tips. So things you should be looking for when installing those products on your own boat, okay? Feel free to raise your hand while I'm doing the presentation. Welcome it. And with that, we're going to get started. So the number one product that I emphasize for all boat owners that are cruising, so people that actually leave the dock to go to an anchorage and are planning to spend any time away from the dock and have to use their batteries in a deep cycle application, is a battery monitor. And without that, really, it's like going in the forest, in the backcountry without a compass or a GPS. You can maybe find your way. You maybe can look at the south and figure where things are, and the moss is growing on the north side of the trees, and you can find a way and you feel your way through it. But at the end of the day, you're not going to really know where you are. You're going to just feel it. And so with a battery monitor, the great thing about it is there's no more guessing. You actually accurately know what's happening in the batteries. And really, when you think about all this mystical battery-related, I guess, information that's out there, legacy information, the real reason is that there was no way in the past to actually know accurately what your battery capacity was. And batteries were almost this mystical thing that were temperamental, that, you know, it depended on what day or what side of the bed you woke up on. And it was kind of like this, well, you know, it's batteries. Well, in actuality, batteries are really reliable. There's nothing wrong with a battery. The problem is not the batteries, is what users would do on the battery and then expect the batteries to last and to be able to withstand any type of abuse for extended periods of time. So the battery monitor gives you the ability of knowing where you are, and knowing where you are is going to maximize battery life, and it's going to come with no surprises. So what type of information are you looking for? You're going to be looking for state of charge, like what is the capacity of your batteries? Are my batteries at 90% of capacity, 80% of capacity, 55% of capacity? So that's really useful. The other thing that's really useful is that information will in turn actually influence what size of battery bank you should have on your boat. One of the most common questions I ask when people ask me a question is, how much batteries do I need? Is, well, what's your amp hour budget, right? And amp hour budget is everything. Your daily amp hour budget is a little bit like knowing how much money do you need to go traveling in Europe for 2 weeks. Well, it really depends on your habits. You know, what hotel are you staying at? Are you staying at a hostel, or are you staying at the Four Seasons, right? Are you staying at a Ramada Inn, or are you staying at a Sheraton? Well, your usage patterns on your boat are going to drive how much capacity you should have on your boat. And a good way to know that accurately, as opposed to me guessing or you guessing, is to have a battery monitor that tells you, and over time, you're going to sense that, yeah, my daily average in the summer is 100 amp hours, or it's 300. And with that information, then you can start knowing that, you can start sizing a battery bank for your use. The other thing that's really interesting is not only is it giving you amp hours, which is kind of the unit of measure of capacity, right? It's like a liter, a kilogram, a kilometer. You're actually also going to know the rate at which you're going through your batteries, right? And that's amps, right? It's a little bit like, a good analogy as a power boater. The rate at which you're discharging your batteries is a little bit like burning fuel on a power boat. The faster you go, it's not a linear correlation. If you go really, really fast on a power boat, your burn rate is really going to affect the distance that you can travel, because when you're actually traveling really fast, you need to be at that top end speed. You're actually burning a lot more fuel than if you would be going slower times longer period of time. And your batteries are the same. Battery capacity is really a function at the rate at which you discharge your batteries. And it's really interesting as an owner to know what speed are you currently doing? You know, it's like being in a school zone, right? Like without knowing and having a battery monitor, are you going 30 kilometers an hour in the school zone or are you going 50? And on a boat, you should be knowing like, what am I doing right now? I'm going to bed. Everything's off. Why am I drawing 15 amps? You know, oh, I forgot. I left the inverter on, right? And the inverter is powering an AC appliance that I left in the kitchen, and I'm going to bed and I'm going to be drawing 15 amps every hour. So it's 15 amp hours every hour for 8 hours. Well, that's 120 amp hours for nothing, right? So you want to like, if I'm going to bed, you know, my lights have got to be off. Well, another thing you want to do, you're looking around, you look at your battery monitor, what are your amps at that given time? And over time, you're realizing, oh yeah, it makes sense. You know, like I'm running the windlass, I'm going to be drawing 80 amps. Flip side, you could also be saying, oh, my alternators are running, but I don't see current going to my batteries. Am I charging? Right? It's a negative deficit. Like I'm seeing a draw on my batteries and my mains are running and I'm not at idle. What? Oh, my alternators aren't working. Why are they not working? Right? So it gives you all this information, and for the owners that we do work that have a battery monitor, the conversations that I can have with them on the phone when they're in Desolation Sound or the Gulf Islands, and I can ask them, put this on, put that off, what are you seeing? It's unbelievable the diagnostics that you can have when you know what the voltage, the amps, and the amp hours are on your boat. For a knowledgeable technician, or you know maybe another boater that's beside you that's an engineer or someone who's a techie or whatever, if you have that information, you can really start making educated guesses on what's going on your boat with that info. So that's why battery monitors are my number one solution, electrical solution.
Jeff, sorry, are these slides being made available on the website?
Yes. Yes, they are. And you actually, there's a link. You can go to our website, and we have a media link. When you go to the media, you'll see there's a section with all our presentations as I do them are being uploaded, and they're going to be left on there. Okay? You can also send me an email. I'll send you the link as well. So what are things that you want to look at when you're buying a battery monitor? Because there's different types. So you want to make sure that you have a shunt. The shunt is what's actually measuring the current going in and out of the battery. That at least 300 amps, right? Because you don't want a shunt that's capped at too low amperage. You want to make sure that you get a battery monitor that will show you capacity in percentage. Why that's important is because, let's be honest, not everyone loves, I'm an engineer, I'm okay with fractions, but not everyone likes fractions, right? And if you are only counting amp hours and you have to remember, oh, my battery is 880 amp hours, I've drawn out 292 amp hours, what is my battery capacity, right? For most people, it's like blah, right? They're gonna be like, but if I give you in a percentage and I say you're at 78% of capacity, that's like just readily available. Like everyone gets that. I'm at 78% of battery capacity. I know where I am. So it just makes it a little easier to have battery capacity expressed in a percentage as opposed to just simply having a counter. The other thing too is there's popular models that we like. I've put 3 models. The Blue Seas ones is new. What I like about that one is actually in one page or one screenshot, it's going to show you amp hours, volts, and amps. The smaller ones that you see on the side, the ones that came out with the Link 10, you have to actually scroll left or right to see all the information. And the problem is sometimes as an owner, you might be looking at it from a distance and you're not going to take the time to go change the setting to see the other values. To see all that at one glance is perfect because with those 3 things, you really know what's happening at your batteries. So that Blue Seas M2 is new and I'm really liking it. The other one too is the Victron, the 702. What's amazing is I wrote an article about it. You can actually have a Bluetooth module with it and you can actually have it on your phone. You can actually have your battery monitor relayed via Bluetooth, your health of your batteries to your phone. Obviously you have to be on board because it's Bluetooth, so it's a local area network. But at the end of the day, it's pretty neat. You know, for some of us that have maybe a little bit bigger boats and the battery monitor is down in, I don't know, down in the cabin on the lower helm and you're up in the pile house and you're like, oh, my battery's charging. You can look at your phone, you're like, oh yeah, my alternator's outputting because I'm getting a charging current underway, right? So it's kind of easy and it's actually not pricey. So those would be 3 models to look for. All right, so what are the tips for doing a battery monitor? First of all, battery monitors are suited for deep cycle applications. Even for some of my clients that have endless money, and I do have a few of those, I still would never recommend that they put a battery monitor on their starter applications. It doesn't matter. It's just, our cars don't need battery monitors because the battery, only thing it does is starts. It goes to 99%, it gets full again. Voltage is a great indication of capacity in a starter application. And even if you have endless money, there's really no need to put a battery monitor on a starter. But on a deep cycle battery is where it makes sense. So they're suited for deep cycle. Make sure, this is the gotcha that actually is missed on probably at least 50% of all battery monitors installed on boats. You have these magical battery banks that have half the current draw going through them, and their fridges are only drawing 20 amp hours a day, and it's amazing how efficient my fridge is, and oh yeah, like everything on my boat is half of what it normally is. I'm a lucky guy. And what they don't realize is they're only measuring half the current going through the battery, right? So it's really important that the shunt actually is a choke point, and no other connections can actually bypass that. The shunt is a device that is connected right beside the negative of the collective house battery bank, and no other negative can bypass it. So everything has to be after the shunt. So it goes from house battery negative to a shunt to a negative distribution bar, and then all your negatives have to be on that negative distribution bar. It's like folks that count cars onto a bridge. If you're only looking at Burrard Bridge and you only look at what's happening on Burrard and you're not seeing the cars that are coming in from Pacific, you're going to be missing part of the traffic. There are cars that are coming from Pacific, and there's cars coming from both ways. So if you're only counting cars a little bit deeper on Burrard, you're going to be like, oh, there's only 80% of traffic. In reality, you're missing all this. You might be missing the S-bar. I've had some clients that tell me S-bars don't take any power. Well, it's because the S-bar was bypassing the shunt, right? Their S-bar took no power. Well, there's no such thing. They have to take power. So you got to be really careful. If you've got numbers that are too good to be true with your battery monitor, and you're the best, and you're out there alone, and you're like miraculous numbers, it's probably because your battery monitor doesn't capture everything, unfortunately. Make sure the voltage and the battery monitor power are connected directly to the battery. Otherwise, if you turn the battery switch off, the battery monitor is going to lose power and also is going to lose the settings, right? So that would be really up. And also, you wouldn't believe at least 70% of battery monitors don't have the amp hours configured in them. So battery capacity can only be an indication of capacity if the battery monitor knows how much capacity you have configured on the device. Okay? So it's really important, and I see that all the time. You'll have a client that has 6 golf carts, and the default setting is 200. And they're going through their battery monitor. They're like, oh my God, I have no batteries. I'm always empty. But what they don't realize is their battery monitor's got the default setting of 200. So he might have drained 200 amp hours. He's got 600. He should be at only 1/3 of discharge, right? 200 on 600. But he's 200 on 200. His batteries say that he has 0 capacity left. So configuring the amp hours on the battery monitor is utterly essential for it to actually give you an accurate representation of your capacity. Yes?
Are you still able to pick up all of your amps if you were to install the shunt on the positive side?
Yes, absolutely. The reason why you don't do that is because the good thing about the shunt on the negative is everything's negative on your boat. Everything's grounded. Your engine block is grounded. Everything's grounded. So if something touches that, it's not going to be hot. The problem is a shunt is a lot of metal, right? So if anything ever touched that accidentally, you're putting a metal broom in your engine, and you're touching the engine, right? Everything that's positive has to be covered. Everything. So now you've got this large device, it's metallic, that you'd have to find a way to cover it, right? Because it's positive. So it's arbitrary. It doesn't really matter if you've got a loop. Are you going to measure cars going this way, or they've got to come back the other way? So you could certainly put it on the positive. You just want to put it on the negative. There's no dead shorts between a negative and a negative. And your whole boat is negative. Everything on your boat is negative. But very few things are positive. And anything that's positive is protected and covered. That's why studs on engines, right on the starter, have a cap. The alternator cap, same thing on the alternator, there's a cap. You're supposed to cover your battery. If you're going to have an insurance adjuster come on board, they'll make sure you put a battery box cover because the positive posts can't be exposed, right? So you cover all positive on a boat. So it would just be more tedious, but it's arbitrary. Doesn't matter. The manual stipulates that it's negative, but I'm explaining to you why they're saying that. Okay, does that answer your question? Okay, great. All right, so that's a battery monitor. All right, inverter chargers. So what's an inverter charger? An inverter charger is basically allows you the benefit of actually running AC loads on your boat without a generator connected to shore power. That's probably, again, the number 2 most popular item that we do on boats. And really, one of the biggest reasons why we end up putting inverter chargers on boats, which inverters are probably larger than they need to be, is because owners want to have the large charger associated with it. Because as battery banks are getting bigger and bigger, you want to have at least 10% of your battery capacity in a charge rate. And an inverter charger is a really affordable way of getting a high output charger. Like a 2,000 watt inverter charger is going to come with a 100 amp charger. So it's common, and especially on my boat, I've got a 2,000 watt inverter, not because I need the watt inverter, 2,000. Yeah, sometimes it's nice to have it, but I wouldn't really bought it. But I really wanted the 100 amp charger because I have an 800 amp hour battery bank. So you need to charge at the right rate, and that's a good way of getting a good high output charger. And buying a 1,000 or 100 watt, 100 amp charger is going to cost you the same amount of money as buying a 2,000 watt inverter charger, because they just don't sell as many. All right, so what are things to look for? First of all, marine-only inverters are a must because all right. They're doing certain things inside that a land-based inverter won't do. I can't get into why. Trust me, if you value your underwater metals on your boat, get a marine-based inverter. If money really doesn't, now anybody who's going to put a non-marine-based inverter on their boat values money. But the question is, what do you value more? The money that you're going to save on an inverter or your underwater metals? And based on the damage that I see on underwater metals on a boat, I can tell you that whatever money you save on an inverter is going to be eclipsed with the bill that you're going to have in certain conditions with the damage that you're going to have on your running gear. So it's really a penny wise, pound foolish to go and get a non-marine inverter, okay? I'll leave it at that. Make sure you get a true sine wave. True sine waves are the ability to run inductive loads. Inductive loads are your Nespresso machine, your microwave, your battery charger, your TVs, anything that's not resistive. A resistive load is a toaster and a heating element, like a ceramic heater. So older inverters, like Freedom, for example, Xantrex Freedom, they're modified sine wave. And they're not as efficient. So it literally is, if you go to the bank and there's a currency exchange, between 12 volts and 120 should be a factor of 10, right? A good true sine wave inverter is going to take 3 points, 4 points to convert from DC to AC. A modified sine wave inverter is going to take 35 points. 35 points. So you're losing 2/3 of your power on conversion on a modified sine wave, which is significant because no one has enough battery capacity. So for you to run that AC load is going to be at a premium. On a true sine wave, it's going to be a 3% premium. On a modified sine wave, it's going to be a 35% premium. And so for some of you that are running AC fridges, this means that your AC fridge is drawing 35% more power than if you took a true sine wave inverter. So for example, this often in the fall, I've got owners that have these big AC fridges and they can't change them. They're custom. They were built around the cabinet. It's be a big deal to change. The best way to make that fridge efficient is to change your modified sine wave inverter and put a true sine wave inverter. Suddenly the fridge is 35% more efficient because you're not losing all that power through conversion. Some of them, make sure it's remote controlled, right? That's not a problem generally with the nicer models. The ability to turn the inverter on and off is paramount because a lot of them have high idle draws. And there's consequences, again, I can't explain to you all the whys, but there are huge consequences of having an inverter on 24/7 when you're not on board. Take my word for it, you don't want that to happen. Again, if you value money. And then popular models, Magnum, Victron, I didn't put Master Volt. Trace is gone now, but Outback is really good. You want big brand names, something you can trust. Okay, Xantrax used to be good. They're not. Unfortunately, they're not what they used. They used to be really good, but not anymore. Okay. Yeah. So purchasing tips. All right. Installation.
One quick question here.
Yeah. Go ahead.
You said they used to be good. I have an older Xantrax on mine. Now, is it? I'm not sure if I honestly can't remember. If it's
Freedom probably.
Modified. I don't remember the model number. That's why I'm asking that to find determine if it's modified or true sine.
It's very unlikely. There was the chances of you having a true sine wave Xantrax is probably 2%. Yeah. I know all these numbers. You're probably like, why do you know this? We work on 400 boats a year. I get on probably 600 boats a year myself. I get to see quantity. So it's just, at one point, you just get to know boats. And so, yeah, it's very unlikely. Xantrax had their peak. Their super popular model was the modified sine wave. It's the most ubiquitous inverter charger out there. Practically any boat that has an inverter, you can put money down that that's what they have. 50% of the boats have that. And they were good at the time, but they were good at the time. They're just failing because they're getting old. But there's nothing wrong with those inverters other than being modified sine wave and old.
So it's just the cost and efficiency.
Yeah, that's right. The newer ones.
Working fine.
Yeah, the newer ones, that's not the case. All right, so what are the things that practically 98% of all inverter chargers, at least 95 for sure, are badly installed? Guaranteed. It's the most common thing, and the reason why is if you buy an inverter, the manual is literally a centimeter thick, and no self-respecting man needs to read a manual that's 1 centimeter thick. It's stupid, right? It's belittling, and they're not going to do it, okay? Whoever wrote that is an idiot. It's simple. Look at the box, honey. I got this. And look, it worked. Hence, I did it right. Okay? All right? And that's not a joke, okay? Literally, when I meet an inverter that was properly installed, there is a handshake happening, high fives. I'm like, you're the one 2016. I'm not going to see it again, okay? That's how rare it is. It never happens. Yeah?
You said you're not supposed to leave these things running continually?
Correct.
Now, the basis behind them is that,
When you're not on board.
yeah, but the basis behind that, leaving it running is if your bilge pump comes on and you're plugged in, you're charging that battery that's running your bilge pump.
Yeah, that's where you're saying, that's where the confusion between an inverter and an inverter charger. The inverter function has to be disabled. The charger function has to be enabled. The problem is if you have the inverter enabled, your battery, you're going to lose shore power, which happens all the time. Then whatever AC appliances you have on your boat are going to be run through your inverter. And if you have a ceramic heater or anything AC appliances, your battery is going to drain. And then the very thing that you're supposed to keep your batteries full to run the bilge pumps, they're not going to be able to run because the batteries are going to be completely drained. And a battery that's completely drained and left uncharged for a period of time sulfates heavily, and there is no resuscitation. Like, if you have a heart attack and you don't have one of those machines within a 5-minute period, you can't come back 2 weeks later. It's like, it's all good, we'll CPR him. Your batteries will not be saved after you're away from your boat for a month, and you're like, oh, Jeff, it's okay, we'll charge them now. No, the batteries are gone. They're 20% of what they used to. You can lug around lead if you want, but there will be a former part of themselves, okay? And you're just carrying on weight. And then what happens is you've got to change your whole battery bank again. And some of you have small battery banks, but some of you have larger ones. And some of the larger ones are hard to install. It's not just the cost of the battery, it's lugging those batteries back on board, right? So I've had clients that have $6,000 bills, $4,000 bill, $3,000. I'm telling you, do not leave that inverter on if you are not on the boat. Sure, leave the charger on, but disable the inverter function on your boat. It's a choice. We're all boaters, we do what you want, but I'm telling you, don't do it. All right, inverter. So you want a Class C fuse, it's not an option. Fuses aren't fuses, it's like there's different fuses for different applications. The manuals stipulate that you need a Class D fuse. You need an on-off master switch. If I explain all the whys, we'll be here literally till midnight. Okay, so I've got to just tell you what. The whys take always longer, right? make sure you have an on-off master disconnect. It has to be a big switch, not on-off of the inverter, all this stuff. It has to be there. The big issue too that you're going to probably either be a pro or hire a pro is most people never separate the neutral bus because it works, but there's huge consequences about that. You have to have an inverter-only neutral bus that are running inverter-only loads. The chassis ground wire is always undersized, always, because people don't read the manual. Okay, so it's like having a tiny shoulder. You know, you got a highway and there's not room for a car. If you got a shoulder this big, it's not a shoulder. You need a shoulder on a highway for a car. If you got a shoulder this big, you can't pull over. So that's what the chassis ground is there for, is to, in case you have something go wrong, you need a secondary path to finish the circuit, right? On AC, it's a 3-wire system, 1 in, 2 out, okay? And then obviously the location of the inverter. Inverters can't be in gasoline engine rooms. They just can't. How often do I see a inverter in a compartment beside the gasoline engine room that has holes this big that the owner drilled? And he's saying, well, it's not in the engine room anymore. I'm like, no, the engine room is everywhere now because you have holes that are like inches wide, and the vapor that are going to fall from your gasoline raker filter are not going to be trapped magically by a force field within your engine room. They're literally going to go in the other compartment beside, and inverters, unlike chargers are not ignition protected, right? So if you ever have a gasoline leak and it gets really warm in the summer and the vapors of fuel are everywhere in that space, and you have an inverter, that inverter, when it turns on or off, it's not ignition protected. You might get a spark. So that's why it's, again, super important that an inverter cannot be in a gasoline engine room or in a space that is somehow connected to that engine room, whatever it is. So vapors cannot get through. Like, you can't even fly. You shouldn't see any light. It needs to be vapor proof, which makes it hard to install. Yes?
Jeff, just off the top, if we went through you to install an inverter, budget.
To properly install an inverter, and this will blow the mind of the people in the room, and I've installed hundreds, well, not myself, it's a 3-day operation. 20 hours to install an inverter. Now, of course, if I have a gun to my head and I want to do it like wrong, I can probably do it in a day and a bit. But again, don't kid yourself, it's not done properly. You're bypassing all these steps. And sure, you can do it in a day maybe and a half, but it's probably going to be undersized wires. You're going to use the wires you have. You'll put the chassis ground to, I've seen it, to a through haul because you figure the through haul is bounded, so there you go. You can take all these so-called shortcuts, but these shortcuts are not, it's not what the manual says. So it's a 2.5 day to install an inverter charger properly.
So like $1,200, $1,500.
Well, it depends on the labor rate that whoever you hire. My labor rate is $108 an hour. So you can do the math. So it's at least $2,000 on labor alone, at least. Okay, so again, but I do things right. There's various degrees out there. That's up to you to decide what's right for you, right? All right. So by the way, that's a bonus slides. This is show now that's really cool. I wrote an article in Tech Talk. You can actually start monitoring your inverter charger over Wi-Fi from remote places. And you're thinking, why would I care that? The newer models are actually almost the hub center of your boat. They're connected to all these different sources. You can see if you lost AC power, if you left your inverter on, what your battery capacity is, all these different things. And you can do that on an app. So, pretty neat. All right, AGM batteries. Why would you want AGM batteries? You want AGM batteries because they've got greater usable capacity, limited venting, they're leak proof, you don't need a battery box. They have low self-discharge rate, and they're great for both deep cycle and starter application. It's like win, 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 win. The downside, cost, double the price of a flooded. That's what it is. So, but remember, it's got 50% more capacity, right? 50%, so that's substantial. So already that offsets double the price. Not completely, but in part. You can buy AGM batteries in all different types of configuration. Group 31, 24, 27, golf cart, 8D, 4D, slimline, L16, all those are like lumber. Lumber is a set dimension. Everyone agrees. Goodfellow, Weyerhaeuser, they do 2x3s, 2x4, 4x8s. Everyone cuts the wood in the same type of standard size, and then you can buy it in different type of materials, fir, birch, maple. Same thing with batteries. You can buy them in known dimensions, different types of materials. Is it flooded, gel, AGM? There's variations of AGM now. And you can also buy them from different manufacturers, East Pendeca, Discovery, right? So there's 3 variables when choosing a battery. Who makes it, what kind of chemistry you have, and what battery size. Okay, but golf cart, AGMs come in all of them from different vendors, okay? So you've got options. They're popular models that I put in there. Oh, by the way, I see this. If you've got a dude selling you a battery from the trunk of the back of his trunk car, and the battery doesn't have AGM sticking on it, but like some weird name, and it's half the weight of a normal battery, and he says that's a bonus, and I've got guys that got conned, and it's like a deal from a deal, and I know a guy, dude, and I'm selling you the $600 battery for $300. Look how light it is. It's AGM. There's no such thing as a light AGM battery, okay? When you buy a battery, you buy lead. That's all you're buying. So it's got to be heavy. And if it's got serviceable caps, it's not AGM, right? An AGM is not serviceable. So there are out there people that take advantage of people that are driven, to think that there's some sweet mystical battery out there at half the price of another battery. And unfortunately, I've seen some clients that have literally from the trunk of a car bought some batteries, and in the end, those batteries were not what they thought they were, okay?
Like AGMs, there's a number of different innards to those batteries, right? Because
Yeah.
I mean, like the carbon foam versus.
Yeah, that's right.
So what's the advantage, disadvantage?
Well, yeah, okay, there's 3. Okay, there's the standard AGM. There's another one called thin plate pure lead, okay, which is now getting a lot of traction, which is another 50% above like for example, a golf cart AGM. Prior to the dollar falling like crazy, last summer, $300. A thin plate pure lead AGM, $450. Unbelievable battery. It's incredible, okay? Really good. Better discharge rate, better capacity, better charge rate, better everything. It's really amazing. And now there's a foam-based AGM battery. And the big thing about the foam-based, and that's another double. So now it's actually more than double. So it's like $700. That battery has, the big thing I was saying is, it allows for being in partial state of discharge in perpetuity. Again, honestly, this could be 8 hours, like no joke, and I could just keep going. Anyways, it's not a gimmick, it isn't, and it's a big thing for people to go offshore. Anybody who goes offshore and are considering AGM should really be looking at the Firefly Oasis, because the battery life and what it's going to give you out in the field is phenomenal. And don't take my word for it, go on forums, go see experts like Nigel Calder and all these different people, and it's the real deal. Yeah, it's more, but it's like your car. Nobody buys a car based on price alone. So don't buy a battery based on price alone. There's more to a battery than just price. Yes? Absorbed glass matte battery. And it's still a lead acid battery. It's not lithium. Yes?
Jeff, I've got a charger that says it's got an anti-sulfation mode or an equalization mode to use. You say they're not serviceable. Are you saying we shouldn't?
No, separate. Again, we'll talk about that later. Okay. Yeah, but yeah, do not equalize your AGM. Some people say you should, but a lot of people say do not do it. I don't think you should equalize a battery on your boat AGM. If you're going to do it in a shop where if something happens, it's going to affect the shop, not your boat. I love my boat. I would never do it on a boat. It's not a workspace for equalizing an AGM battery, okay? Don't take the chance. Again, people are like, what's equalization? I only have an hour. All right, installation tapes. Make sure that when you size your batteries, you size it so that you'll never go below the lowest point of discharge. An AGM battery typically can go to 30. The newer ones can go to 20. So you can go from 100 to 30 comfortably and have the same discharge cycles as a flooded. Flooded is 50, AGM is 30, and the better AGMs, the thin plate pure leads, or the foam can go all the way down to 20. So you have more usable battery capacity. So hence you need less batteries to have the same capacity. Make sure you have a charger that's AGM compatible. Not all of them are. And you can't mix in parallel, certainly different battery chemistry. So you can't have like 4 golf carts and say, oh, I'm going to put my new pair of golf carts are going to be in parallel with the old pair. are going to be flooded at AGM. You can't do that. Like if you're going to have one bank, it needs to be all the same. Okay? All right, the next one is smart battery chargers. So what, I know it's, for some of you it's silly, but a battery charger, what does a battery charger do? A battery charger takes AC power and makes DC power. Now it's not a converter, but converters are kind of a misnomer for a charger. And converters are things that you see a lot on older AC panels. And those are devices that you could never really leave on for permanently because they would boil your batteries over. You know, they would trickle charge. Trickle charge is not a word that's used anymore. It's just a word. It doesn't mean anything. But they got it wrong by about 0.1, 0.2 volts. And it would actually boil your batteries slowly. It's kind of like death by 1,000 paper cuts, or you know, eating a grain of rice, or water torture. You know, just one drop on the forehead will drive you nuts. And that's what it is, you know. You're thinking, well, what's a big deal? Well, it's not a big deal for 24 hours or 48 or a week. But if you leave it on for 4 months, that battery will boil over. And it happens all the time. All the time. People are like, oh, damn it, I left it on, I shouldn't. And then they got to change, you know, 6 golf carts, 8 golf carts. So if you have a non-smart charger on board, ask yourself, are you really the type of person that is so ritualistic that will never, ever, 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 ever forget to turn it off? Because if you forget to turn it off, you're going to boil your batteries. And you might not boil them all the way down, but don't kid yourself. If your batteries are really thirsty and you see the plates, whatever surface area of your battery is exposed, it's gone. Like that battery's gone. And next time you charge it, it's going to overheat much quickly. And you're going to be topping it off at the time. So it's always going to be thirsty. Okay? So it's going to go from a battery that needed so much of maintenance to like twice or 3 or 4 times the amount of maintenance. So you're constantly going to be topping it off because it's going to have a higher resistance under charge. And also you want to make sure that when you size a battery to a charger, and this is probably the most overlooked item as battery banks are getting larger, is to have a battery charger that is sized for your battery bank. These two things are not independent of one another. They work in concert. It's not like, I had a client, for example, he had 4 8Ds and a 20 amp charger. I'm not joking. I don't know if you realize 20 amps, it's like working, like forget minimum wage. It'd be like on $3 an hour and thinking you're going to retire. It ain't going to happen. You can't even feed yourself. He couldn't be on board and charge his batteries. Like he'd have to actually leave because then the loads would stop. And then he had enough, and it would literally take him days to bring it back up. But his batteries would prematurely die, and he'd have to change them frequently. And he didn't like batteries. But it's not that the batteries were bad, it's that he charged them so slowly that they would sulfate. So you need to have at least 10% of battery charge, 10% of charge rate as a function of battery capacity. So if you have 4 golf carts, let's call it 400 amp hours in a 12 volt setting, you need to have a 40 amp charger. If you have, like I do, 8 golf carts, 800 amp hours on 12 volts, I need at least 80 amps. Now you can get away with it and you won't know that your batteries are not 100% charged, but you'll age prematurely. Like the batteries will not last you as long. Like my batteries, I made it to 10 years and 2 months on my boat with my flooded batteries. It's pretty good, right? Now I have some clients that have done better, but I use my boat 100 days a year. So that's a lot of cycles. But I also do follow the rules on discharge, follow the rules on charging. You know, I follow the ritual, right? There's a method. I didn't invent it. It's out there, and that's what a little bit of what I'm talking about. So definitely make sure that your charge rate is appropriate for your battery capacity. And originally on your boat, the batteries were always smaller than what they are now. People have been adding batteries. It just happens. We just want more capacity. People find capacity somewhere. And so the problem is that the charger is overlooked and only the capacity is looked at. Okay? All right, things that you should look at if you're a battery charger. 3-phase, so that means you should have bulk, absorption, float. You know, battery type, make sure that it does all the battery types you want. That's temperature compensated is really important. Remote panel is not a bad option, right? So they'll be able to, you know, see what's happening at your batteries. Make sure you have a marine model. Do not miss this step. Now this is not a joke. Do not forget that. No Canadian Tire charger on. You can do it, but again, you're gonna really regret it later. Very much so. Popular models that we use, Pro Mariner, the Pro Nautic is phenomenal. They have from 10 to 60 amps. Great charger. Never had one fail in the field. I've put hundreds in. Never had one failure. So incredible. And I'm not the only one vouching for it. An awesome charger. And then Mastervolt does really good higher output chargers, like 100 amps. So we often use those ones on bigger boats. 100 amps. It stops at 100, but you can get 100 amp at 24 as well. So really good chargers. Make sure the charger is 10%. Fuse at the battery. Again, that's a big thing that's missed. Connect always at the battery, not after the switch. That's a big no-no. Make sure the breaker is able to handle the new size of the charger, because if you're changing from a 20 to 60 amp, that breaker might have been only 5 amps before. Now it might need to be 10 amps of the AC. And commonly, the dip switches on the older chargers, on the Xantrax, the True Charge 1, which are great, the 2 are awful. You can't get a 2, like remove a 2 on your boat. It's awful. There's pictures on the web of actually pallets of True Charge 2 being returned. Literally pallets, like stack like this high of True Charge 2 being returned. Okay, I've had it. We've seen like dozens of boats that had it, that had huge problems. They'd fry all the batteries. They'd overcharge. They don't die like in not charging. They die in overcharging. And you're not on your boat every day, right? You might be somewhere. You're on a vacation. You come back. Your batteries are completely boiled over. Done. And some boats that can be really expensive. It's not like one Group 31. It could be 8 golf carts. It could be 12 golf carts. It could be 2 8Ds, 4 8Ds, right? You've got to change them all. So big deal. Make sure that you have also the right battery type set on the charger, because those dip switches are easily brushed. You know, you can brush them. People are in the engine room. Your mechanic doesn't know. He's in there. It's a tight space, and suddenly the dip switches goes from flooded to gel, right? That would be really serious. Or the wrong battery type, battery temperature. There's all these different, or the wrong charge cycle. They'll go fixed. I have one client who was telling me his batteries are always dying. He actually only had it set to bulk and absorption, so he was always overcharging his batteries. He's changing his batteries all the time. The charger was hidden. He didn't know where the charger was, didn't understand. And it was simply a dip switch that had been missed. So really important. And then, you can also add a second charger. You know, so we've got it often where we're adding second, third chargers on boats to reduce the charge rate. That's a really popular thing that we do for owners, so that you reduce your genset runtime. All right, solar panels. So why do people do solar panels? I'll do a presentation on Sunday. Keep the batteries topped off because I've got it on a mooring buoy. I want offset refrigeration. I didn't have refrigeration before. I had the right batteries. Now I've added refrigeration, and I'm always in a deficit. So I want my solar panels to offset my refrigeration. Jeff, I want to be able, I can stay 2 days at anchor. I can't add more batteries. I don't have the space. I want to be able to stay another day. Jeff, I want to be neutral. I never want to worry about power. I had a client just today, came in the booth. He's got a 45-foot sailboat. He's like, I want what you have. I don't want to think about power anymore. I want to be completely energy neutral. I don't even care about running my alternator. I don't want to care about anything. When I leave my anchorage and I get to the other one, I always want my batteries to be topped off. So you've got all these different desires in terms of solar panels. You can mount it on canvas or hardtops. It's lightweight and durable. 5-year warranty. Like a 170 watt panel weighs 5 pounds. It's literally a factor of 10 with a rigid. So what are the things that you should look when you're purchasing a flexible solar panel? There's a long formula, but there's a shorthand formula, luckily. So what you do is you can say, if you have, for example, a 100-watt panel and somebody says to you, well, how many amp hours am I going to get out of the panel? You divide by 4. That's going to give you your daily amp hour output in summer from mid-June to mid-September in a typical, somewhat sunny day. Clouds, but it's not gorgeous. If it's beautiful weather, you divide by 3. If it's terrible weather, you divide by 5 in the summer. But divide by 4 is the middle of the road. That's what you're going to get on average. Make sure you get good quality, right? You'll see the construction. Buyer beware. When you're buying a panel, look at the panel before you buy it. You can tell right away the quality. Some panels which have built-in diodes allow for shade protection. Some panels don't, again. And then the popular models, there's a panel built in Seattle and Washington, Orinco. They're really good. I know they were doing presentations here. Gioco, which is in Italy, and Solbian, which is in Italy. And Solbian invented the line. They're the ones that came up with the product. They're the first, so they've got the biggest market share, but they command the highest price point. If you're going to install solar panels, make sure you need a controller. So you're going to need an MPPT. Make sure you get an efficient one. You're going to need MC4 connectors. And you want to offset the voltage drop. So don't really make sure you make a good decision on the wire size. You don't want to lose 10, 15% of the output of the solar panel, which you've paid a premium because let's be honest, it ain't cheap, right? You don't want to lose 10% of the capacity every day of your solar panels because you chose a gauge 14 wire versus a gauge 10 because you made a decision only on ampacity, right? Voltage drop is the biggest single factor when sizing a wire, predominantly on a boat. Ampacity is there, but generally it's not the weak link. Voltage drop on a 12-volt system is generally the weak link. And so you got to size for both, but generally the wire size is going to be determined more by voltage drop than ampacity. And then make sure, and this is another, I can't tell you again why, but make sure that the panels are directly connected at the battery. Not at the panel, at the battery. Again, I wish I could tell you all the whys, but unfortunately I'd be here till midnight. So again, I'll answer questions if people are curious and they're about to do it, but make sure you wire it to the batteries. And it's got to obviously be fused. All right, the next product that I'm going to talk about really quickly is those fuel cells, those ethanol fuel cells. No noise, no vibration, no smoke. I've got clients that are taking out kind of like bothersome gensets that need a lot of love and don't seem to ever get enough and are expensive to fix. And they don't really have AC appliances on boat. They're taking those out and they're putting ethanol fuel cells on board. I have one on my boat. I couldn't put a generator if I wanted to on my boat. But if you don't have a need for AC and you don't really have a need for a DC generator, which there is validity to that, then boats that have a limited battery bank, you can't increase the size, or you have a limited alternator, or you don't like moving with your boat and you like staying put, an EFOI might be a good idea to put on your boat. It's pricey, it's not cheap, but it's, for me and what I recommend to clients, it's not the first step that you do for power, it's kind of the last step. Once you've exhausted all other options, battery capacity, alternator, maybe putting solar panels and whatnot, that's when your back is into the wall and you're like, I still need power. What am I going to do? That's when you should explore an EFOI. Choose the right output. So some of them are 85 amp hours a day, 140 amp hours, or 210. This is all at 12 volt. Make sure you carry fuel on board. You can't get fuel everywhere. So I always carry an extra container. A container has 1,000 amp hours of power, right? At a flick of a switch. It's a slow feed, right? They're not feeding you like a fire nozzle, right? It's not like an alternator or high output charger. It's gonna, like the 210 model is gonna be outputting 8 amps, but 8 amps every hour, right? Overnight when you're sleeping, it makes no noise. It's like the purr of a cat. You can't even hear it. Like it's impossible. Like you have to focus. You have to lift up the hatch and you're like, oh yeah, it's there. You put down the hatch, no cushion, it's gone. So make sure that you have fuel on board. And then what are the steps for installation? Well, you want to make sure that it needs some ventilation because it does create heat. It outputs distilled water, so you got to capture it or it goes in the bilge. On sailboats that are basically keel step mast, it doesn't matter because there's always water coming down the mast. But for some of us that have dry bilges, you're going to want to have the water go down in maybe a jug, and then you can capture that and you can use that for your flooded batteries to top them off. It's distilled water, it's pure water. The fuel cartridge needs to be close to the unit. It's not like it can be far away, so you need about this amount of space. And then the leads that are off the battery of this is really for a battery that's really close by, but sometimes on some boats the batteries can't be close to where the fuel cell is. So if the fuel cell is further, like 20 feet, 30 feet, then the gauge of the wire should be changed to be able to offset the voltage drop that's going to happen on bringing that current all the way to the batteries. All right, external regulators. Really common thing. We do that a lot for sailboaters, and sailboaters, fast boats like Tiaras actually come with them stock because a Tiara is actually kind of like a sailboat. It's crazy to say that, but they run their engine for a really short amount of time. Well, sailboaters do it, but not because they want to. But it's here, I just can't run their engine for 4 hours a day. It's just, they're going to be covering so much ground at one point. It's crazy. They'd be going from South Island to North Island, you know. So they're running for an hour, maybe 2. And so what they're trying to do is they're trying to capture all that energy from their engines and send them back to their batteries. Sailboaters want the same thing. They want to be able to half an hour out and half an hour in, right at the end of the day, and within that duration, to have the maximum output from an alternator back into their batteries. And the way to drive that is through an external regulator connected to an alternator. And an alternator gets power from the rotation of an engine, right? It's a mechanical thing. It's only when either the boat is loaded or unloaded, i.e. you're in gear or not in gear, the alternator is turning, but an external regulator is going to make sure that you pretty much can double the output of your alternator, whatever it is, with that device. Maybe not double, but 80%. Okay, so there's good reasons to put it in a boat. Makes the newer models allow to actually be set for different battery types. You can even do custom charge profiles for those high-end batteries. So if you have a new high-end battery that wants a specific charge profile, you can do a custom charge profile on that regulator. So we've done that. Really one of the biggest benefits is that some of them now have remote battery temperature sensors, temperature compensating battery, or charging a battery at a temperature compensated voltage is a really good idea. You can really get a higher charge rate out of that. So those alternator regulators have that option, and they also have a temperature sensor on the alternator, so in case it overheats, it's going to pull back. So instead of having this complete meltdown on your alternator because it's overheating, the regulator is going to be sensing that the temperature of the alternator is too high, and it will pull back on the field voltage. It's what drives the alternator, and say, hang on a second, this alternator doesn't have enough sufficient ventilation. Maybe it's 100 degrees outside and you're running your engine for 8 hours and it's really hot. So the alternator is running really hard because your batteries were really empty. This would actually at one point pull back and say, I can't charge right now at full capacity. We'll pull back the field to let the alternator actually cool down. Make sure the units are sealed, because normally they have to be really close to an engine and it gets really hot in there. And so you want, some models actually are fully sealed units. If you're going to change the alternator, or not even, but put a regulator, you're going to probably, like I said, increase the ampacity by about 80%. So the wire that's from the alternator to wherever it is probably undersized. So the engine manufacturer didn't know you were going to do that. They size everything to what's there. If you change one variable, look up and downstream and upstream and make sure that everything can accommodate this new output from that alternator. And also, I always recommend to make sure that if you go directly from an alternator to a battery, which you should, but that your engines aren't like that, you should fuse the lead at your house battery. All right, this is a product that a lot of boats, what's a common problem on a boat? I have an engine, or 2 engines, and I have 3 battery banks. I have only 2 alternators. How do I get one alternator to go 2 places? Right? Common problem. It's on many boats. And they were diode combiners. It's like a gate valve. It only lets current go one way. So the 2 batteries can't see each other, but the alternator can see both batteries. It's great, but diode combiners would actually make you lose about 50, 60, 70% of your alternator output in heat. So you could have a 100 amp alternator, but your effective charge rate would be 30 amps. And at the day, there was nothing else to do. It was either you have the convenience of having it automatically dispersed to 2 places, or the owner has to manually turn the switches on and off. And realistically, a lot of builders were like, my owners aren't going to be doing that. I can't trust them. And if they don't take it off parallel when they get to a dock, I'm hooped. I only have 1 battery. And if they discharge the battery completely, the next day they can't start the engine. So a lot of boats have diode combiners, like lots. And so there's new devices now that actually allow to replace those with 0% efficiency loss. Well, like maybe 1. So before it's like 60, 70% efficiency loss. Now it's like 1 or 2% efficiency loss. So it's an easy upgrade on a boat that has diode combiners I have one product in my booth. This is the one I have, which is easily retrofittable. There's different kinds again. Some of them do prioritization of batteries. I really like this one. It's easier to install. It's really good. Honestly, most boats have diode combiners. You'd be shocked. It looks like a fin. It looks like a heat sink. You look in your engine room, it's got 2 or 3 posts or 4 posts. And you look at it, it looks kind of old, and you're like, why are all these fins? It's the heat from the diodes need to be dissipated. So that's what's blocking the current from going the other way. So that's really good. What are the things to look for when you're doing that? Again, trying to emphasize, if you've got alternator leads, make sure that they're fused. And also make sure that it's unbelievable how many wire sizes on the alternator are allowing the right ampacity to go through, but you might be losing 10% or 15% of your alternator output because of voltage drop. Right? Again, it depends. You know, some people it doesn't matter. They have enough power and they don't really care. But if you're trying to recharge your batteries quickly because you don't have time, or you don't move a lot every day, or you have a sailboat and you want to sail, or you've got a Tierra, you're only running your engine for half an hour a day, then it's really good to make sure that you've got voltage drop, and you limit that voltage drop by having a larger wire between the alternator post and the batteries. All right, battery combiners. These are devices that allow batteries to actually see one another when there's a charging voltage. So it's effectively like you turning the battery switch to parallel, or both, and then disconnecting it when the charging voltage is not there. So it's pretty handy. It's pretty popular. I've installed literally thousands of that. I mean, I'm #1 buyer of this stuff in BC for sure, because it takes the user out of the equation. Right? The big problem with a user is there's a user. And if you forget to actually put it back to 1 or 2, right, and you leave your batteries in parallel all the time, then it's like having your savings account in parallel with your checking account and saying to the bank, by the way, if I ever get an overdraft on my checking, I want it to come from my savings. And don't ask me, I just want take it from my savings. And then you don't have separation of 2 bank accounts. If you're going to do that, you might as well have 1 bank account, right? And then the problem is if you overdraw on your checking, you're going to be taking out from your savings. And then in the morning when you're going to start your engine, on one of those days, you're not going to have time to get a boost cable from a friend or whatever, or start the genset. You're going to have drained all your batteries and you can't start your engine. The great thing about that is it connects and disconnects automatically. So you're not part of it. Make sure you size, they're not all sized for the same. There's little compact ones, bigger ones, medium ones. There's all different models. Some of them can be, oh, by the way, an ACR can also be a remote battery switch. Like it can say, by the way, I want them to be in parallel now. So there's some that can be manually activated. I want my batteries to be in parallel. I want them to be auto. I never want them to be in parallel. VSR, BEP makes some really good models. Probably better than the Blue Seas ones, but the Blue Seas higher end ones are good as well. ACR is automatic combiner relay. It's a marketing word for that. VSR is voltage sense relay. Same thing. They're just their own definitions of the same product. Again, you need a fuse. Make sure you never bypass the switch. It has to go to the battery. Huge implications if you go to a switch. Switches are convenient because they're downstream, right? People they're further from the batteries and they'll take a shortcut to a switch. You got to be really careful. And a lot of them, you have to fuse the ground sense wire, which you're probably thinking, why? That's stupid. There's a reason. Again, I can't tell you why, but make sure the ground sense wire is fused. Last product is galvanic isolators. What is a galvanic isolator? Galvanic isolator is basically to protect or reduce stray low voltage currents between AC and DC grounds. 10 years ago, I wouldn't be talking about it because they weren't fail safe. And they used to fail. And suddenly you're thinking you have a shoulder on a highway, and the shoulder, without you knowing that it's there or not there, disappears. Right? And you're driving, you can't see the shoulder, but you assume it's there, and if you have trouble, you want to pull over. Well, these things, the shoulder would disappear. You wouldn't even know it would disappear, and now suddenly you're in a 2-wire system. In Vancouver, there's really old houses. Really old houses could have 2 wires. This is like, we're talking 100 years, okay? This is going way, way, way back. So if you're in a 2-wire AC system, it's not even generational. It's like a century. So those devices would fail open, and suddenly you wouldn't have a shoulder, and no one would know. So you'd lose your AC grounding connection, and no one would know. And you would be doing that to stop stray DC current. So people were not really liking it, and so not everyone installed one. But these new ones are actually fail-safe. So when they fail closed. So you'll stop protecting your boat, but you won't stop protecting your boat from grounding issues. So, I mean, damage to your underwater metals is going to be a problem for your insurer. Losing your grounding connection is a problem for a life, right? So that's the trade-off, right? You might lose protection to your underwater metals, but the flip side is you'll never, ever have someone that's going to get electrocuted because there wasn't a return path for the hot. So make sure you choose the right amperage, 30 or 50 amps, right? Shore power cord. Make sure it's fail-safe. We really like the Newmar one, the 30 amp or the 50 amp. And the really important thing here is that you want to install it. Assumptions on boats are really bad because other than a builder, owners, on the internet, it's called PO, previous owner. So blame the previous owner. And the previous owner could have bypassed and found a ground somewhere and intercepted it. And anything is possible. Anything, truly. Take the sheeting off, the insulation, just put a wire in its ground, it's fine. So the only way to make sure that nothing bypasses the galvanic isolator is to see your AC shore receptacle, to literally see it from the inside of your boat, have the wire, intercept it, and then have it go back to the AC shore power receptacle. I've got clients that say to me, oh, well, I'll put it somewhere from A to B, and I know where B is, but I'm like, do you know from A to B, are you certain that that wire was never intercepted? Right? And the question is, maybe you take a chance, and there's nothing wrong with it, but if it was intercepted, the diode, the fail-safe galvanic isolator is not going to be effective because something is going to be able to bypass it. So it needs to be a choke point. The only way to make it a choke point is to have it as close as humanly possible to the receptacle, and you know for a fact that nothing can bypass it. And that's how you make sure that it works. Last thing, my bonus thing is everyone should, if you care about electrical, you should have a clamp-on meter. Multimeter, they're awesome. And it's really useful, even if you don't know how to use it, to have one on board. So when you call a technician and you're in Desolation Sound, that I can have you do tests with it. Because without it, I'm really in the black. But with this, I can narrow down a problem really easily. And I can say, yeah, your inverter's done. This is done. You got to go to Campbell River. You got to go to Powell. Stay there. It's fine. Do this and that. You'll bypass. It's all good. Because that's the tool that technicians have to really isolate circuits. Okay?
Jeff, would you pay the extra money to be able to sense DC amperage?
Absolutely.
Okay.
Yeah, essential. Really good point.
So it's like 120.
Yeah. And that's actually what I say. Make sure it's a DC and AC clamp-on.
Okay.
I remember the first clamp-on meter I bought was at Home Depot. When I bought my boat, I felt justified to buy a lot of tools. It was my dream. Came home, I had literally buckets of tools. It was like, honey, I have to. I'm going to save money. You see, this is why I'm buying tools. And I bought, and I still have it as a reminder of being an informed shopper, I have a clamp-on meter that I bought at Home Depot that does only AC. And that's really not that useful because most of the circuits on a boat are DC, and I really want a DC and AC multimeter. So make sure you have that. It's really useful. You can buy them online. There's all these different models, but make sure, and also the rating is really good. Make sure it does at least 300 amps. 1,000 is better. But 300 will get you most places. 1,000 will give you a starting circuit or a thruster circuit, right? So that's basically it, everyone. I knew I fly by here. I'm going to open the floor to questions.
Why the clamp-on versus the clamp-on? I mean, you're talking about the one that sets when you put
The
it on
flux.
top of the insulation. Right?
Yeah, because it's magnetic flux. Because otherwise, the question is why do you want to clamp on? There's two ways to measure current. You can actually put an inline device, which is a shunt does, or you can actually measure it through flux, magnetic flux. That's why people don't want to live under high power lines, because there's a magnetic field. Every wire has a magnetic field, and it's directional. Right? It goes either that way, I remember from class. Either goes that way, you remember too, or that way, right? And actually the clamp-on meter, if you go put it this way or you turn it around, it's going to show you a positive or negative number, and it's going to change. And the great thing about it is you don't have to disconnect anything. You literally just put it on a wire, right? You clamp the wire.
That's the advantage.
Well, yeah, it's great. I mean, can you imagine what type of device you'd have to intercept a thruster motor? Like the job it would take you to, oh, by the way, I'm going to take that wire, intercept it, lug it, right? Put a device in. It'd be like 4-aught wire, right? It would be like forever. You put a clamp-on meter, you're done in 10 seconds. You get it you put it in line, it's impossible, right? It's possible to do it at a shunt because you do it once and you measure everything all the time, right? But actually now new Blue Seas and more sophisticated panels, what they're doing in the factory is they're actually putting flux, literally monitors everywhere, Hall effect, and they're putting it everywhere. And instead of the wires actually being intercepted, they're putting literally these, like a clamp-on all these wires, like North Havens have that, and higher-end Ocean Alexanders, bigger Ocean Alexanders. And what they're going to do is they're simply going to have sensors that measure current through Hall effect as opposed to a shunt. It's just easier to wire in a panel. And they'll do that in mega yachts too, because otherwise it's just easier to install. But it's not as common. Questions?
Did you put an external regulator on a 50 amp alternator, or do you upgrade the alternator first?
No, the first thing I would do is I would put an external regulator.
And it's going to still give an 80% increase in.
Yeah, absolutely. Yeah.
Really?
Yeah, absolutely. Whatever you're getting, like you got to remember when you have an alternator, the alternators, that's a cold rated output. So they're doing that. Everyone's doing the same thing. So it's marketing, right? You'll never get 55 amps after 30 minutes. Well, you'll never see 55 amps, period. Okay, so it's 55 amps, cold rated. Within half an hour, it's hot. Derate by 10-15%. Internal regulated, derate by another 2/3. Voltage drop, because that's at the output of the post, not at the battery, derate by another 10-15%. So that's why your alternator, 55 amp alternator, is giving you like 30, 25, right? And it's going to give you higher output at the beginning, but then it's going to be derated when it gets hot. So all those factors play, and that's why your alternator is not giving you what you think it should. But they're all like that. And also 55 amp is at maximum RPM, right? The top end of the curve. Now, how often are you top ending an alternator? Because the alternator is sized to the pulley ratio, so that wide open throttle, whatever it is on your boat, it's not going to actually break. So let's say the alternator is meant to 11,000 RPM max, or 10. It's sized so that when you wide open throttle your engine at 33 or 36, that alternator is not overspinning. Now, you're never going to go at 3,600 RPM on your boat while cruising, but that's what the pulley ratio is. You're throttling back to 2,100. That means that alternator is outputting, again, at 2/3 the output of maximum output of the alternator. So all these things are compounding to make your alternator not give you what you think it should, just the way it is. That's why a bigger alternator is better also.
And it'll work with any.
Yeah, you've got to just modify it for external fields.
Okay.
Yeah, an alternator shop will do it for like $50. They'll remove the external regulator and they'll modify it and they'll give you a wire. The field wire is like it's basically like an accelerator in a car. That's what decides. You don't need to move a lot in accelerator in a car, like an inch, 2 inch, and that's enough to go from 0 to 200 kilometers an hour. And that's what field voltage does. The field voltage goes from 0 to 12, and that variation is what makes the difference between going like 5 amps or 100 amps. Other questions? Yes?
You're setting up the bat monitor for capacity. Are you doing it for the total capacity of the bank, or what your usable capacity, like 50%?
Good. That's a good question. So on some battery monitors, the capacity of the battery monitor is limited. Like the Link Light Pro only does, like, say, 1,000 amp hours. So now you're thinking that's a huge battery bank. It is, but we have clients that have bigger. And so then the problem is if they have a Link Light Pro battery monitor, I'm going to tell them, unfortunately, and it screws the numbers around, but anyways, it's not an exact science either. Unfortunately, the number I'm going to show you is really what's available capacity. The older monitors had really good ones. The Link 10, for example, they allow you to decide what your floor is going to be, right? And they say, do you want the battery capacity to be a reflection of actually what's available or what you should use, right? Which is nice. So on my boat, I don't actually show all the amps I can have. I only show the amps I should take. So my battery capacity is only set to not all amps. It's amp hours. It's what I should only be taking. So when I get to red flashing, it's not that I'm actually empty. It's time to recharge. I'm using my full range. Otherwise, you have to remember what's the halfway point, right? And when you're in the red and you're in the red, you've gone so far. Like you ran a marathon and then you went to do another one, and then you're like, yeah, I won't be damaged. You're not going to come out the same. Like if you take a battery from 100% and you go, like I had a client today telling me he brings it down to 10.5 volts every time, like 10.5. I'm like, this is crazy. Like it's literally like running like a double marathon, right? You're not the same person after that. You can't, like there's some people that can do it, but your battery can't. And if you do that, you can do with the deep cycle batteries, a flooded 50 cycles. Versus if you go to 50, 300. So it's a factor of 6. So some of those owners that change their batteries every year, every other year, they should change every year, but they're stubborn. So the next year, they're just not working, right? And it's too embarrassing to change every year. But they'll take their boat for a summer, they'll boat out in Desolation Sound, take it down every day because they just can't be bothered. They'll have a battery monitor, but they don't listen. Can't be bothered. They'll ruin their batteries in one summer. They'll ruin them, completely ruin them. The next summer, they're too stubborn to change them. At that point, they're just running the gen set. And their batteries are terrible, but they blame the batteries. And then the next summer, then they change their batteries again. So that's why you want to bring your batteries never if it's flooded below 50%. 10.5 volts is, it's the last step running away from a grizzly bear. Like it's, you gave it everything on the dance floor. Like there's nothing left. There's nothing left. The battery is done. You can't go past 10.5. If the light's dim, you're way, way out there. That's what's hard with a battery, right? That's why the battery monitor tells you way sooner. You know, you're like, oh my God, I still have so much capacity. But it's deceiving. That capacity comes at a very high cost in terms of wear and tear.
No lower than 12 volts?
Yeah, this is the problem with voltage. Voltage is only accurate. It's like breathing. You're like, breathing? Breathing is only an indication of your health if you take it in conjunction of your activity level, not only in the moment, but what you're doing recently. I can be breathing really, really hard, but if I did the grouse grind in 46 minutes, I kind of expect it. And it doesn't mean that I'm breathing for my life, that I'm unhealthy. But if I'm sitting in the couch and I'm panting, then I know that why are you panting and you have no exercise? So voltage is only an indication of capacity when you take current and you take time. So you have to know what have you done recently and further away. So that's an art, right? Like I can tell you, yes, what have you been doing? What are you doing now? Where are you going? And I'm like, yeah, okay, that voltage seems right because that's all I do, right? I live in this world. But as an owner, I get owners that are freaking out. They're like, oh my God, my voltage, brand new batteries, my voltage is 11.5 volts. What's going on? I'm like, what are you doing? Well, man, we were doing coffee. My wife dried her hair. You know, we were doing this. We're watching TV. What are the loads on the batteries right now? Oh, we're running at about, you know, I got a daughter. It's about negative 222 amps. I'm like, you're sprinting for your life for the last 30 minutes. Yeah, you have a large battery bank, but as soon as you take away that 200 amp load, give it a little bit of time, the voltage is going to rise again, right? So it's a little bit like, okay, for example, good analogy, your engine starter battery. An engine starter battery is going to go below 12 volts no matter how big it is when you start that engine, unless you have a massive battery bank, right? Like it doesn't matter if you've got an 8D, you crank that engine, it's going to go to 11 volts, 10 volts. That's normal because you're asking 1,000 amps, 500 amps. Now it's not that the battery's bad, it's you're literally asking everything it's got for that moment. So voltage is only an indication of capacity when there has neither been a charge or a discharge for 24 hours. Now that happens on a starter battery all the time because once you finish with an engine, it's not being charged or discharged, right? So capacity, voltage is an indication for capacity for an engine battery. But a deep cycle battery, how often on a boat do you have neither a charge or a discharge on a battery? Never. I mean, you're always using the battery. So that's where the voltage is, you got to call someone. You got to go, hey, sorry to bother you, but something's not jiving. Can you tell me? And that's where voltage is really hard. And how could you accurate do 50, 60, 70, 30, 20% on voltage when you've got to have all that information? You can't. You'll overshoot. You'll undershoot. You'll be staying too much time in the top end, which means your batteries take forever to recharge, driving you crazy, right? You want to stay in that sweet spot, the bulk charging, which is between 50 and 80, or between AGMs, 30 and 80. Those are your bookends, right? If you stay in that, your charge rate is maximum. Whatever, the batteries will take whatever you give to them, pretty much. So that's the reason why voltage is not a good indication of capacity. It's good, but it's very limited. Any other questions?
Yeah, what would you expect an AGM to read after you've taken it down to 30% state of charge?
Same, it's going to be lower than a typical battery, absolutely. Like it's not going to be 12.2. It's going to be, I think, 25%, I think is 11.8 or 12, 11.9, I'm going by memory. Like I know on the top end, right? AGM or lead acid is going to be same voltage. 100% battery, 12.6, 12.8, right? At 12 volts, of course, right? 24, you just double. And then you go 12.6, 12.8. 12.4 is going to be 75. 12.2, this is all at rest voltage, right? No discharge or charge for 24 hours at 77 degrees Fahrenheit. Okay, like you're like, oh yeah, temperature matters, right? If it's in the bilge and you're in the Gulf Islands, it's 55 degrees, or you're in Pendrell Sound and it's 80 degrees, your battery voltage is going to be different. This is, see, it's not easy, right? So 12.2, and I think 12-ish, around 11.8, 11.9 is around 25%. It's going to be the same. That's why, again, it's okay to have the voltage drop as long as you have a battery that can tolerate that deeper discharge and still give you a reasonable amount of cycles. And a cycle is from full to that level. Other questions? All good? Thank you, everyone. And if you've got anything, let me know. I'm going to be in my booth upstairs.